Okay, so for now we are going to learn another form or another pattern that we can write out the complex number. Okay, so if you have a look for learning outcome 9.4, you will realize that here they want you to know how to express your complex number in polar form. Okay, so this is the polar form actually. And also another pattern we call it as exponential form. So this is exponential form. This is polar form, this is exponential form. All right, so these two pattern are the other pattern. Okay, I mean the other pattern that we write out our complex number. Previously, when we write the x plus yi, so that is actually Cartesian form. Okay, so please wait for a while. Okay, so like this, the x plus yi is actually Cartesian form. And all the while we are learning this, right? Okay, so for today we are going to learn another two patterns. So what first of the pattern we call as polar form. Okay, then the second pattern that we are going to learn is the exponential form of a complex number. All right, so these two patterns, right, generally it will be useful for some kind of questions, especially the multiplication and also division. Okay, when you are having the polar form or exponential form, right, sometimes when you want to carry out the multiplication and division, it will become easier in a certain type of question. All right, so you need to know how to put it in the correct way of polar form and also the exponential. All right, so let's have a look for the notes. Okay, so again, as what you learned before, you can see that this is actually the complex number, right? Okay, so to find out the argument, so this is the argument. You draw a right angle triangle for the complex number, and then you should know that the argument measure from the positive x-axis. And then the r here will be the length of the complex number. Okay, so if you look at this triangle, right, from the diagram, you know that x is equals to r cos theta, y is equals to r sine theta. From this triangle, okay, the triangle, right angle triangle, you can form the equation x over r is cos theta, therefore x is r cos theta, y is r sine theta. Therefore, when you want to put x plus yi, you substitute x equals to r cos theta, y equals to r sine theta, so you can rewrite it become r bracket cos theta plus I sine theta. Okay, and then you should know that the r and also the theta here means what? R is the modulus, okay, of the complex number. The theta will be the argument of the complex number. Okay, so this pattern itself, we call them as polar form. We call it as polar form. Or another name is modulus argument form, because from the expression here, you can see the r and also theta, where r is the modulus, theta is the argument. Okay, all right, so this is what we have for the polar form. And after that, when you want to express it in the exponential form, we use the Euler's formula, saying that ei theta is equals to cos theta plus I sine theta. Okay, so when we change the polar form, okay, into the form that involve the exponential, we can change it like this. So this is polar form, right? So you can make it become z equals to r. R is, you just copy this one. Then you change this into the Euler's formula, become ei theta. All right, so we call this pattern as exponential form of a complex number. So for this exponential form also, you need two value, okay, to write out the exponential form. The first one is r, which is the modulus of the complex number, and also the theta, which is the argument of the complex number. So you can see that these two patterns, right, generally you need the modulus and argument of the complex number to write out the expression in the form that they want. All right, so we have two. The first one here is the polar form or modulus argument form. Another one is exponential form. All right, okay, so we will just practice something here, which is very, very easy. Okay, so if we look at example 11, they want you to refer to example 10 they want you to write the following complex number in polar form and also the exponential form. So you refer to your example 10 that we discussed in the previous video, right? We already find out the modulus and also the argument for all these complex number. Okay, so as an example for part 1, you just refer back now. What is the modulus for the part 1, the modulus z? So I believe that you already find out that the modulus z is square root 34 from example 10 that you try out in the previous video. And then for the argument, what is the argument z? So the argument z that you get is 0.540. Correct or not? So this is what you get in example 10, the answer for modulus and argument. So now if you want to write in modulus and argument form, which is very easy. So what is the z here? The z will be square root 34 cos theta, so cos 0.540 plus I sine theta, so I sine 0.540. So this is what we call as modulus, polar form or modulus argument form. Okay, and then if you want to write it in the exponential form, then it will look something like this. So square root 34, which is r, all right, and then e I theta, so 0.540, this is theta, and then you write as I. All right, so this is what we have it as the exponential form. So the red color one is polar form, the purple color one is exponential form. All right, so before you want to write it out in polar form or exponential form, generally what you do is you just try to write out you just try to find out the modulus and argument first, then only you can write them in the form that you want, which is polar and also the exponential. Okay, so we already saved some time because you already get all the argument and also the modulus in example 10. Okay, so for part 2, part 3, part 4, part 5, and part 6, you just try to write out the correct pattern for exponential and also argument form. All right, so exponential and also polar form. I will just write out the final answer for you. So I think you should pause the video here first. Pause the video now, and then you try to write out all the answer, then you come back and check your answer. Okay, because there's no discussion here. You just need to refer and see whether your answer is correct or not. All right, so the red color part will be the polar form. All right, then the purple color one later is the exponential form. Yeah, so I will just straight away write out all the answer for you. Okay, so I hope that you already completed all the polar form and exponential form by yourself, and then these are the answers. Okay, so again, before you can write them out in the polar form or maybe the exponential form, you need to find out the argument and also the modulus of the complex number first. Okay, so this is quite basic. All right, okay, so just to let you know, if they want you to convert the exponential form or polar form, go back to the Cartesian form. So how can you do that? All right, so here I just show you a very simple example. Let's say I'm having this z equals to maybe 8, and then I'm having cos theta, which is maybe pi over 3 plus I sine pi over 3, let's say. Okay, so this is a polar form, right? So how can I change it become the Cartesian form? So very easy. So to change the polar form into the Cartesian form, you just expand the bracket first. So you're having 8 sine pi over 3i. Then what you do is that you just try to press calculator and get so cos pi over 3 means 60 degree. So cos 60 is half, right? So 8 divided by half, you get a 4. Or you can just straight away press the calculator to help you. And then plus, then this one will be square root 3 over 2. So square root 3 over 2 divided, you are having 4 square root 3i. So you can change it back into the Cartesian form very easily by just pressing the calculator. So from Cartesian, you change it become polar. Is more troublesome because you need to calculate the modulus and also the argument first. All right, so I hope that you get what I said. So the same thing happened for exponential form. So if let's say they give you an exponential form, let's say they give you 4 and then e, then pi over 6i, let's say. Okay, so again, you have to change it back, become the polar form first. So 4 is the modulus you just copy. E pi over 6i can be written as cos pi over 6 plus I sine pi over 6. Then again, you try to expand. And by pressing the calculator, you maybe can get the value lah. Alright, so cos pi over 6 means cos 60. You're having 2 square root 3. Then plus, this one is 0.5. Multiply with 4, you get 2. So this is how you change the exponential form and also the polar form back to the Cartesian. So from Cartesian to polar or exponential, you need to find out modulus and also the argument first. Okay, so in the next video, we are going to discuss some questions that we are going to use all these different patterns of the complex number to answer a certain type of question.